So fine. Last class we have discussed about the delays and data flow modeling, Verilog operators. In that, arithmetic operators we have discussed, right? So arithmetic operators are addition, subtraction, multiplication, division, all these things. So these are the arithmetic operators. And then today we will discuss about that logical operators. What is that logical operators means? So we will get single output like either true or false. True, if both the inputs are true, that means you will get the output is true. That means depends upon the operation, either AND operation or operation. So if any one of the true value we are getting means, so whatever the expression we are written, if that is true, then you will get the true value, otherwise false value you will get. So that means in the logical operators you will get either 1 or 0. Okay, so that's it. So how the values will be considered here? So logic value high means, suppose logic high means whatever the value we are giving. Suppose I am taking the variable x. In this variable, I have given the value like 5. Okay, this will be treated as a high value. Okay, any value is present means 1, 2, 3, so and so on, so up to infinity numbers you are considered means all these values are treated as a high values. And you are giving 0 or unknown or high impedance, these values means it will be taking as a false values. 0 means false, and sometimes I am giving unknown value and high impedance value also. Sometimes I am giving the x value, sometimes I am giving the uh, z value, that is unknown propagation. So that means any value we are not getting, that means some corner cases you need to verify. For that purpose, I will provide that unknown value or high impedance value. See, here 5 value is there. That is the true value. And then 0 means 0 is always false. In here, at logical operators, we are having logical and, logical or, logical not. So logical and means, so two symbols we are using, and symbol, two symbols are using, because bitwise operators are also there. So there is a difference between the logical operator and bitwise operators. Bitwise single operator is used. Here two operators are used: logical and, logical or, logical not. So here logical AND means if both operands are true, then only I will get the value true. Here 1 means high values, that is true values, and 5 and 3 also true, or 1 and 2 also true. Okay. So in this case also we are getting the value like true value only. So that means high value only we are getting. If any value is low, that means 0, and then you will get 0 only. Okay, and then different operators we are using like AND operator, logical OR operator, logical NOT operator. How the OR operator will work means, if both the values are low, then only we will get the output is low. If any one of the output input is high value, then you will get the value high. Suppose 5 or 0 you are taking, then you will get the true value. And then when both the inputs are low, okay, 0 or 0, then only you will get the false value, 0 output you will get. Clear?
Yes.
Some basic examples like this is the module and then module name. I am representing that input values A and B. So here A value is 1 and B value is 0, and then representing result. So here inside the initial begin, I am doing some operations related to logical operators. Result A and B, if doing both the A and B, so see A value is 1 and B value is 0. Okay, if any value is low, then your output should be low. That is the logical AND operation. And then logical OR operation, if the both the values, any one of the input is high, see here A is high and you will get the output is high. And the NOT operation means complement of the input. So that means whatever the input you are taking, high value you are considering means you will get the output is low, and low value you are considering means you will get the output like high. So that is the truth table here: 0 0 0 1 1 0 1 1. So AND operation or operation, if both the inputs are low, output is low. Any one of the input is low, output is low in that AND operation. If any one of the input is high, okay, that gives the output 1 at the OR operation. So complement means if any input you are considering, that complement values we are considering. Okay, so that is the truth table summary. See how the logic will occur here means 0 means false, non-zero values, whatever the values you are considering, all the non-zero values will be treated as a true values. Okay, and then unknown value and high impedance value you also propagate that. So some unknown values we are considering at that time, we are giving that high impedance value or unknown value. So these are the operators like AND operator, OR operator, NOT operator. See, bitwise AND operator is single AND operation only there. In between the bits, we are doing the AND operation. Here, entire values we are doing the AND operation. That is the difference. See, here 10 is considered. Okay, 10 value we are considered. Here 5 is considered. So then do the AND operation between the 10 and 5. That is the logical operation. But bitwise operator means whatever the 10 you are considering 1 0 1 0 and then 0 1 0 1 you are considering 5. In between the bits you need to do the AND operation. Okay, so that is called as bitwise operators. Okay, and here whatever the values we are getting, boolean values, the truth values and false values only we are getting, but here some value we are getting. That means bit by bit we are doing the operation, then only we will get some value here. And here result should be 0 or 1. Here depends upon the operand size. Suppose you are taking 8 bit and suppose you are taking 2 bit, based on that you will get that. So these are the short circuit representation of A and B. We are doing the AND operation and getting the result here. And then A and B, we are doing the OR operation and getting the result here. So if B is not evaluated means, so that means there is no other value for B means here not evaluated. So then the result will be getting either 0 or unknown value. Depends upon the values, whatever the values you are giving to for the input as a B. And handling unknown values and high impedance values. See, we are doing unknown AND operation with any unknown, and we will get the result unknown value. But 0 and unknown means 0 only we are getting, because true and something means, so something value we are getting, unknown value we are getting, because 1 into x means x value we are getting, but 1 into x means 0, sorry, 0 into x means, so you will get 0 only, because false into something means always false only we are getting. Okay, here not like that. If any value true, okay, true is OR with unknown value, true value only coming. Okay, true is the highest priority. Here 0 unknown OR with unknown value means, so false, and then unknown value means unknown value we are getting. That means something value we are getting, not doing the AND operation. OR operation we are doing. So OR operation means whatever the unknown value we are giving, that value only we are getting. And then not operation you are giving unknown value means unknown value only we are getting. Okay, so this is the logical operator. How we are applying the logical operator? So basically we are applying for AND operation, OR operation and NOT operation. These are the symbols for the AND or NOT. Okay. So and then common mistakes are logical AND operation. We need to use two AND operation. Don't use single AND operation. That is bitwise operator. And then we are expecting one when while both the inputs are high. So then only I am getting the high value. If you are ignoring that Z and unknown values means your propagation may affect your simulation. That means sometimes I am not covering the unknown values and high impedance values means corner cases are not covered. Okay, so that also we need to consider and then check that if you are giving unknown value to your AND gate and then true value you are giving, so true value only we are getting. Otherwise, otherwise whatever the value you are getting, so we need to check that. Okay, so false value you are giving, and then unknown value you are giving. At the time or operation we are doing means unknown value we are getting. Otherwise, and then under operation you are giving high value, and then unknown value you are getting unknown value only. Okay, so because unknown value is multiplying with some other means unknown value only we are getting at the output side. That the thing we need to remember in the logical operators. Okay, and then equality operators, we are doing two types of equality operators we are having. So this also compare the two statements. If the two statements are true, then only we will get the true value. Okay, so if you are not getting, the condition is not true, so your condition is not satisfying, then you are getting the false value. Okay, so in this case, equality operator, we are having two types of operator, case equality and logical equality. In this logical equality, unknown value is there means you are getting the unknown value or high impedance value only. It is not considering, it is not equating that unknown value. But case equality, suppose 1x10 is there, and then here also 1x10 is there. This is my a value and this is my b value. I am equating a equal to b. So if your case equality operator, three equal to's are used, then comparing that each and every value are same, then only we will get the true value. Here the unknown value, high impedance value also considered in the case equality operator. But logical equality, that unknown value and high impedance values are not considered. So cannot resolve here. You will get the result like unknown value only. Okay. So if you are giving any unknown value like this one, see 1 0 1 x1. Okay, this is 1 0 x1 is my input, one input a value, and then 1 0 1 1. Here one unknown value is there. Then I am doing the logical equality a equal to b. You will get the output like unknown value only, because one value you will get unknown value, then your result is also unknown value. See, and high impedance value is also there, you also get the unknown value, any value. So high 1 x z 1 is there, and then 1 x z 1 is there. Then you are doing the logical equality, you are getting the unknown value only. Sir, here we have 1, and then x is also equal, z is also equal, 1 is also equal, both are same, right? Why we are getting the unknown value? So this logical equality doesn't evaluate the unknown values and high impedance values. Okay, and case equality if you considered means, then you will get the value true, because all the variables are true. At that time, sometimes unknown value you are considering either 0 or 1, depends upon the condition it will be considering. Clear? Same way. See, this is the example for that, how we are comparing the values. A and B values I am giving. So, A equal to 10 x1 and then 10 x1. If both are equal, see here both A and B are equal, but case equality, logical equality, we are doing this. Logical equality, we are getting unknown value. And then case equality, you are giving that case equality, you are getting the true value. That's what. So and not equal here also, see here not equal, sir. So then why you are getting unknown value here? Don't consider that unknown value will be either equality or not equality. So then only you will get unknown value only. And then logical case inequality you are considering means, so here true unknown value, sorry, zero value we are getting because it is not true. The equality condition is satisfying that. Then why you are saying that not equal? So case is not equal, then you are getting the false value 0. That's what. See, that is the values related to logical operators, sorry, equality operators, logical equality, and then case equality. In the case equality, unknown values are comparing. See, logical equality, unknown values are not considering. See, logical equality, we need to use double equal to, and then case equality, we need to use triple equal to. So any unknown values or high impedance values you want to check, that go for the case equality, don't go for the logical equality. but most of the cases we are using the logical equality only. Okay, logical equality only we are using, because it is whenever you are giving the unknown values, I need to get the unknown value only, and don't consider that either 0 or 1. In the case equality, you are giving unknown value or high impedance value, you will getting that either 0 or 1, depends upon the equality condition satisfaction. Okay, so this is the summary: equality, and then case equality, and then not equal, logical equality, not equal, and then case not equal. So these two operators are used in equality operators. Okay, and then relational operators. So relational operators, how we are getting the values means, it is comparing between the two operators. So we are considering two operators A and B. If A greater than B condition is true, then you will get the true value. If condition is not satisfying, you will get the false value. Here also we will get either false or true value only, and cannot compare that unknown values. Okay, whatever the unknown value are giving, so that will not compare here, because we are not considering any unknown values with relational operators. If you are comparing unknown value, then you are getting the unknown value only. And then so less than equality, equality operator, and then case equality, all the conditions greater than equal to, and then greater than condition, all the conditions, if you are considering any unknown value or high impedance value, means you will get unknown value only. Clear? So don't consider any unknown value or high impedance value for the relational operators. Okay, we need to consider either true value or false value. That means give the any value like 5, 7, 2, 3. In this way we'll give the values, or some 0 you can give the value. So then only integer values only it is considered here. See, what are the relational operators are there? Greater than, less than, greater than or equal to, less than or equal to. If A greater than B, if the condition is true, then you will get the result is true, because 5 is greater than 3. So condition is true, and then you will get the operation like true value. And then A less than B. Less than B means here 5 less than 3. Condition is false. So then you will get the false value. So and then 5 greater than or equal to 3. So condition is true. You will get the true value. And then 5 less than or equal to 3. Condition is false. You will get the false value. So that's what. Same way, I'm considering an example like module name. In between that, I'm taking the variables A and B, and then result for storing the output here. And inside the initial begin, I'm considering the relations. So result equal to A greater than B. So I'm applying the $display condition. You will get the display like true value only, because you are giving 5 and 3. So then you are getting the first condition true value, and then second condition false. Your result will be false, and again result equal to A greater than or equal to B. Then you will get the true value. Okay. While comparing that, so whatever the numerical values we are giving, that only we are comparing here. If you are giving any unknown values, it is not comparing that values. See, what are the different conditions we are considering here? 5, 3. So condition is greater than, condition is true. Greater than or equal to also true. Less than and less than should be false. Here the values are reversed, then less than value, less than or equal to values are true. Greater than condition and greater than conditions are false. Here equality condition. Okay, so we are not considering greater than or equal to, we are considering. So that should be true, and less than or equal to also true. But less than and greater than is false. Here also 0, 0. Greater than and less than are equal to 0, true. Same condition here also, 7, 2 and 2, 7. Same consideration we are considering here. Okay, same example we are considering. So these are the relational operators: greater than or equal to, less than or equal to. Okay, so this is the example for the greater than condition. Suppose you are doing some addition operation, b plus c, or adding, and then comparing with a. So my a value is 5, and then b value is 3, and then C value is 2, then 5 greater than 5, condition is false. Okay, so r greater than or equal to, you are considering this condition is true. In that way also we will consider. And similarly, some equality operators and case equality operators are also combining that. How we are combining means, suppose a greater than b we are considering, that should be equal to b less than c. Okay, if your b less than c is correct and a greater than b is correct, then if both are equal means, then only you will get the values true. Okay, so that means equality operators are also combining, and then relational operators are also considering. So in that combinationals also it is considering. See, here also another example for conditional, like a greater than b, and then a, if condition is true and then a is greater and condition is false, b is greater, and then display if both are not equal means display that a equal to b. In that way, I'm considering two if conditions here. Okay, one if condition is fails, and then other condition also you can take that. See how the relational operators and equality operators we are comparing that. Greater than, less than, greater than, less than or equal to, greater than or equal to, equality, not equality. These are logical, and then triple equal, this will be case equality. So I am considering the operations like how I am considering means, suppose a equal to 2 value I am giving, b equal to 5 I am giving, and c equal to 3, and then so this value I am considering a is less than c, and then how we are doing the AND operation. Some logical operators are also we can apply here. Okay, relational operator, a less than c, and then a greater than b. So this condition is false and this condition is true. True and false, you are getting the operation like false only. Okay, in this way also we will consider. Okay, so because relational operators we are applying, in between that some arithmetic operations we can also apply, or some logical operations are also we can apply, and equality operators are also we can apply. All the operators we can apply for this relational operators. Okay, so here magnitude is considering, that means the values will be considering here. Here not the values and then each matching. Okay, whatever the matching values are there, that only considering, because here 1 0 1 0 0 1 0 1 you are considering. If both are equal only, so then each bit by bit we are considering that, we are checking that both are equal or not, then only we are considering the values. Okay, here not like that. Greater than, less than, equality operator means magnitudes only. Here 5 value is there and 10 value is there. 10 is greater than 5, yeah, magnitude is satisfying the condition. So in that way we will consider that. Clear? So after that, bitwise operators. How the bitwise operators we are doing here? So bitwise operators means we are considering single bit by bit. How we are doing the bit by bit operation means AND operation, OR operation, and then XOR operation, and then NOT operation. All these operations we are doing here. How we are doing the bitwise operator means, suppose here 1 1 0 0 1 0 1 0 you are taking 1 1 0 0, and then 1 0 1 0 you are considering. Do the bitwise AND operation, then you will get one value based on the your size of your number. Here 4-bit number I am considering, then your result is also 4-bit number. Okay, so 1 and 1 I'm getting the 1 only. 1 and 0 0, 0 and 1, so 0, 0 and 0, so 0. So 1 triple 0 is my result. Okay, so and then sometimes we will do that OR operation, like 1 0 1 1 0 0, and then 1 0 1 0. Bitwise OR operation single pole only we are using. So this way 1 and 1 or 1 you are getting the 1, 1 or 0 1, 0 or 1, 1, 0 or 0, 0. If both the inputs are 0, then you will get the output is 0. If any one of the input is high, output is high. That is the OR operation. And then exclusive OR operation 1, 1, 0, 0. Again, you are taking that 1, 0, 1, 0. So doing the XOR operation in between the two bits. If both inputs are same, output should be 0. And if the two inputs are different, your output should be 1. Here also 1 and here 0. So 0, double 1, 0. In that way I am getting the XOR operation here. And also I'm inverting operation, we are doing that. Inverting operation you are considering for single value only. Whatever the value, whatever the single operator you are considering, A is considered, A is 1100, you are applying the negation operation like this, or you can also apply the not operation like this. Both are same, but this is logical and this is bitwise. Okay, so in the logical operator you are considering the value, so high or low. This is logical not operation, this is bitwise not operation. So bitwise not operation you are using that some whatever the value we are considering 1100, just complementing that 0011, I am getting the output here. Okay, so that is the output. And then inverted XOR. Inverted XOR means that is XNOR. XNOR means whatever the value you are considering, suppose 1100 and then 1010 you are considering. XNOR operation means, so that is complementing the output, whatever the output you are getting. So that means if both the inputs are same, output should be 1. If both the inputs are different, your output should be 0. But previously, in that exclusive OR operation, if both the inputs are same, output should be 0. If the inputs are different, your output should be 1. Okay. So in other case also we can apply in the exclusive OR operation. If odd number of ones are there, okay, odd ones are there, okay, your output should be 1. Even number of ones are there, even ones are present means your output should be 0. In exclusive NOR operation, this case is reversed. Even number of ones are present means, okay, your output should be 1. Okay, output should be 1. Odd number of ones are present means your output should be 0. Okay, so that is the exclusive OR operation and exclusive NOR operation. See, if both inputs are 0, if both inputs are 1, I am getting the output is 1. If both inputs are different, output should be 0 here. Okay. So that is the exclusive NOR operation. These are the different examples for 4-bit operators like AND operation, OR operation, XOR operation, not operation, and then exclusive NOR operation. Okay. Here also we can apply different operators like bitwise operators that are also considered to in between the AND operation, OR operation, and then logical equality operations. All these things will be applied here also. Okay, so these are the practical examples like 8-bit I am giving, and then lower 8 bits, and then so in between these two operators we are doing the AND operation. Then we can consider that. So this lower 8 bits only we are considering. Lower 4 bits means these 4 bits only we are considering. That means we need to do the AND operation in between that 1101 and then 1011, and then lower bits means what is the value 1011. We do the AND operation in between them. Okay, so all the AND operation here there is no value means all are zeros. Okay, do the AND operation here 0 0 0 0 is getting here 1011. So all zeros and 1010 you are getting the output side. Okay, sometimes we will consider the lower 4 bits and then higher 4 bits you are considering means, so upper 4 bits you are consider. Then consider the upper 4 bits, do the AND operation like this 1101 and then 1011. Higher bits I am considering means same, and then lower bits will be 0. Then you will get the 0 0 0 0, and then 1 0 1 1. So in this operation we are getting. Okay. So this is the
Yes.
bitwise operators. How we are implementing in hardware means, so basically AND operation we are using, OR operation, exclusive OR operation, NOT operation. All these things are gate level simulation we are using that. So gate level conversions. This is the hardware implementation of your bitwise operators. And don't use this double and. This is logical operators. And don't use this. This is the bitwise operators, so don't use this logical, not this one. So some of them are in logical operators. Instead of this, we are using this not operation. Sometimes bitwise operators using this. Instead of this, we are using logical not operation. Then at that time you will get the syntax errors, or some compilation issues are coming. Okay, don't do that. So different operator precedents are also there. See, negation operation is applied, after that and operation we are doing that. That is also possible. So bitwise and not operation we are applying that. So and operation, bitwise and then not operation we are applying. And then bitwise and operation we are applying. Bitwise and operation and XOR operation. So combination of the operators are also we are using. So one time OR operation we are doing, and then XOR operation with A and B. So one time you are doing AND operation, other time you are doing OR operation, after that you are doing exclusive OR operation also. Okay. So this combination of operators are also allowed here. And shift operators we will explain the next slide. So what are the shift operators are there? Left shift, right shift, and then arithmetic shift, arithmetic right shift, all these things. Okay.
Yes.
So these are the operators: AND operator, OR operator, XOR operator, NOT operator, exclusive NOR operator, all these things. So this is the evidence for the all operators. And conditional operators. Conditional operators means you are doing that just like a if else conditions. If the condition is true, the expression is true, then only the true value will be coming here. So this is the condition. So it is like a ternary operator. Conditional operators are like a ternary operators. How if else conditions work, so same thing will be getting. If condition is true, then true value we are getting. If condition is false, else value we are getting. Okay, so same condition here also expression. This is the condition, and then expression for true and expression for false. Okay, if suppose I am considering a greater than b. If this condition is true, I am getting the value, so true value like 1. And if your condition is false, I'm getting the condition is like 0 value. Then you need to consider one example: a equal to 2, b equal to a equal b equal to 1. Then 2 is greater than 1. Condition is true. Then you will get the true value 1 in that way. So see how we are applying the conditional operator for the module example. My module name, and then I have considered the two values like a equal to 1 and b equal to 0, and then output is y. Here initial begin I am applying that if a greater than b, condition is true, 1 is greater than 0. Okay, so then condition is true, I am getting the output like 1 here. So your output is 1 here. And similarly, here also we can apply like this. So condition is true, output y equal to 1, or condition is false, so output y equal to 0. This is the if else condition. How we are considering the if condition. Same thing here also applied, ternary operators. And nested ternary operators are also there. Sometimes we will apply the nested ternary operators. How the nested ternary operators are applied means, if one condition is true, if A is greater than B, and then go for the true value like A, and then false condition if it is false, and go for the another condition b greater than c. Okay, if b is greater than c, condition is true, then c b value is getting, or condition is false, c value we are getting. That means one if condition you are doing, if a greater than b. If a is greater than b means I am getting the output like a. Or else if condition we are doing that. Else if condition b greater than c. If B is greater than, my output should be B, or else condition, my output should be C. How we are applying the nested if condition? Same way in ternary operators also we will apply the different nested conditions. Okay, so in sometimes if the condition is true and again other condition will be getting, if A is greater than true, and then again I am checking that other condition if C is greater than D condition. So if this condition is true, then only it is going to this condition. Otherwise, see, there is no else condition. Based on without else condition, we are checking the true or false values. Sometimes we are using latches. At that time, we are using only single value, single if condition, and don't use that else condition. The else condition we are skipping that. So latch condition, one condition is true means then only we will get the other value. Okay. This is the nested conditions. So if true table, how we are getting that? If expression is true and then output condition is true only, then if condition true value we are getting. And then false condition means the expression false will be appeared here. Okay. If you are giving any unknown value and high impedance value for the expressions, it will not consider. Then you may get unknown value only. Okay. So how we are applying that continuous assignments for this ternary operator? If I am using 2 by 1 multiplexer, two inputs, these two inputs are depends upon the select line. If select line is 0, your output should be A, and if select line should be 1 and your output should be B. How I am getting the condition? If select line depends upon the true value means 1. True value you are getting means I am getting the output like B here. Otherwise, I am getting the output like A. Similarly, I am giving the select line equal to 0. If false condition, I am getting the output like A. Otherwise, I am getting the output B. So this is the ternary operators we are applying. In continuous assignments also we are using, and then procedural assignments also we are using. If y equal to select line is 1, I am getting the output is A. Okay, sorry, select line is 0, I am getting the output is A. And select line is 1, I am getting the output is B. Okay, depends on your selection. So whatever, sometimes some of the people consider A equal to 1 here and then B equal to 0 here, and then you are giving the output and select line. So based on this circuit, so when you are giving the select line should be 1, I am getting the output like A, okay, or you are getting the output B. So that means if it is not 1, you are getting 0 only. B value only you are getting at the output side. Okay. So that is the multiplexer example for the ternary operators. Okay. Same way, some bitwise and operations are also we can use, and operator precedency. So how we are giving the operator precedency means, see here A greater A plus B, we are doing that. So after that C value will be getting. So this example, most of the times we need to consider the parenthesis. Okay, because why we are using the parenthesis means the parenthesis will be evaluated first. After that, addition and then conditional statements will be taking. So this is the operator precedency. Then depends upon the operator precedency, you will get the values. Okay.
What is the parenthesis?
Parenthesis means brackets. See,
Understood.
so these are the brackets. Okay. And what else we are missing here? Bit width rules. Bit width rules means consider that whatever the 8-bit value we are considering, same value will be taking place here also other conditions. So based on that, whatever the width you are considering for A value and B value width also we need to consider same. For that we need to append the values like zeros before the value. Suppose your A value is 4 bit. Okay, 4 tick B1010 and B value will be 2 bit. Okay, so then 0 0 only we are considering. then I'm checking that A greater than B condition and A less than B condition. Here 2 bit is there, here 4 bit is there. So magnitudes you can consider means 10 greater than 2 means 10 greater than 0 means if condition is true. Okay, but you are not considering like that some equality operators or ternary operators we are applying means if both the sizes should be maintained same. So for that I am giving that 4 tick B 0 0 0 0. If before that you can add zeros means that value never change. Same value will be taken. If you are adding zeros before the values means then your value will be changing. Okay, because see 1 is there. I want to make it as 3 bit. So 2 zeros I am adding at the left side. I am not adding the zeros in the right side because if you added the bits in the right side means your MSB value position will be changing.
Yes, sir.
Don't change that position. Okay, that is the thing. See, here also we are applying the different conditions like ternary condition. Condition is true, expression 1 is getting or false, expression 2 is getting, and then description for this condition 2, that is expression for 1 is true condition and expression 2 is for false condition. So this is the conditional operator. So then shift operators. How we are doing the shift operators here? So shift operators, we have two types of operators, logical shift and then arithmetic shift. Okay. So here also we are shifting the bits by right side or left side. Okay. See, this arrow is indicating like this. Okay. That means left shift you are doing that. Okay, and your arrow is looking like this. Okay, then you are doing the right shift operation. Okay, so arithmetic right shift and logical right shift, what is the difference is whatever the MSB bit position is there, see you are doing the logical right left shift, the LSB bit position should be placed with 0 here, and then logical right shift you are doing means, and then your MSB bit position is filled with 0 here, 0 fill at the MSB bit position side. Okay, but in that arithmetic side LSB value will be 0 but MSB position should be filled with 1 here. Okay, because this is the signed value replication. Signed value means always we need to place the 1 at the weighted position. Whichever value we are shifting, suppose 1010 you are having, this could be shifted by right shifted by 2 means, so how it is shifting? 0 is coming out here and then 1 is here, 0 will be here, 1. This vacant position we need to place the 0 here.
Yes, sir.
And other position other also you can doing means, so here also 1 is coming here and then this is 0 and 1, here two vacant positions are there, though that will be filled with zeros. Okay, so that is the thing. See how the waveform examples here showing that 1010 you are taking. So then one right shift you are doing means, so right shift you are placing means, so arithmetic right shift you are doing. See left shift you are doing, that means one left shift you are doing. A value is 1010. So 1010 you are doing the right shift operator means this one is coming here and 0 is occupied here, 1 0, here vacant position is there, that will be filled with 0. Okay, so that is the logical right shift operation and left shift operation. This is we are done left shift operation. This left shift is filled with 0 vacant position, whatever the vacant position is there, that should be filled with 0. See, you can observe that. So this is the value 10, right? 1010 means what? So 1, 2, 4, 8. So 8 plus 2, 10. Okay, your value is 10. You are doing one left shift operation. that value is divided by 2. So division by 2 is happening. That means 10 is divided by 2 means you are getting the
5.
value is 5. See, 1010 is the value. You are shifting by 1 left shift operation. 1 is getting out 0, 1, 0 and vacate position is 0. Then you can check that it is divisible by 2. Okay. So nearly 4 value we are getting, right? Okay.
Yes.
So that is the thing we are remembering here. Okay. And just think about it. Okay. So actually, whatever the arithmetic right shift is there, so that should be okay. So that is called whatever the value we have, that should be multiplied by 2, not division by 2.
Yes,
Okay,
sir.
multiplication by 2. That means suppose 0, 0, 1 is there. You are doing one right shift operation. This is 0 and this 0 is coming here. This 0 is coming here. 1 is there and then this place is 0. Then this value is 1. This value is multiplied with 2 means so 1 is multiplied with 2 means then you will get the answer is 2. Again, 0, 0, 1, 0 is there. You are doing another right shift means 0, 0, 1, 0, 0. Then you are getting that this value is multiplied with 2 means you are getting the 4 value.
Yes.
Okay. So that means every time one right shift operation you are doing means that is the powers of 2 value you are getting. 2, 4, 8, 16. In that way we are getting the value. Okay, so that thing you need to remember while doing the arithmetic right shift operation you are doing means you are getting that value like multiplication by 2. Okay, and then that is unsigned values and some signed values are also there. That means arithmetic values we are doing that. This is the logical and this is the arithmetic value. Whatever the integer, see you are doing the right shift operation means so one right shift operation means it is divisible by 2. Whatever the value you are considering, suppose 1010 you are considering. Okay, you are doing right shift by 1. Okay, right shift by 1 means 0 is going out and then 1 is coming here and then 1 is coming here 0, 1. Okay, you are placing 0 here. Then check this condition 0, 1, 0, 1, that is value is 5. Then 10 divided by 2 is 5, you are getting that. Okay, so arithmetic right shift you are doing means it is divisible by 2. Arithmetic left shift you are doing means it is the result will be multiplied by 2. Okay, remember that. This is the example condition we are considered. Okay, A value is 4 bit and B value is 4 bit and result 1, 2, 3, 4, 4 results we are considering. Here minus 4. How we are representing the minus 4 means so negative value is there, that value should be 1. Okay, and then 4 is 0, 1, 0, 0. Then double 1, 0, 0 is the minus 4 representation.
Yes.
Okay, or simply you can sometimes you can represent 2's complement also. Okay, so 2's complement how we are representing 4 is there. Okay, 0, 0. Okay, so 0. Then we need to do the 2's complement for this 1, 0, 1, 1. Okay, do the plus 1 here. 1 plus 1 means 0, here 1, 1 plus 1 means 0, here 1. So then 1, 1, 0, 0. That also you will get the negative value 1, 1, 0, 0. Okay, so better to do 2's complement only, then only you will get the best value. Okay, so without any confusion you will get the, that means see here minus 4 you can write means here negative sign 1 and then 4 you can consider 4 bits or 3 bits. We are getting confusion. So then don't get confused here. 0, 1, 0, 0 you can take that. Do the ones complement here 1, 0, 1, 1 plus 1 you can add. So then that is the 2's complement number 0, 0, 1, 1. This is the 2's complement of 2's complement of minus 4. Okay, this is the value we are getting. See, here I am doing the right left shift operation by 1. Okay, whatever the value we are considering 1010. Okay, so left shift by 2. Then I am getting that value like 10 into 2. Okay, 10 into 2 means what is the value we are getting?
20.
So 20, right? So 20 that should be value here 1 is going out, right? This is the 1 and then 0 1 0 0. Okay, this is 4 and this is 16. Okay, so 16 position and 4th position both are 1. Okay, then 16 plus 4 you are getting 20 value here.
Yes, sir.
Okay, that is the multiplication operation. Okay, multiplied by 2 operation. Similarly, here right shift operation you are doing that. That is divisible by 2. Then 1010, this is the value. You are doing the right shift operation. 0101 you are getting. So this bit is shifted here and this shift is shifted here and this bit is shifted here. 0 is going out. Okay. So then 0101 is the output I am getting.
Yes, sir.
Okay. So these are the shift operators, and then see arithmetic right shift and left shift. So right shift you are doing means then you are getting the whatever the value you are considering. See b value I am considering. What is the b value here? Minus
Minus
4,
4.
right? 1100. I am doing the arithmetic right shift operation. Then 0 is going outside. Then 0 1 1, whatever the value is there, vacant position, that should be placed with 1.
Yes, sir.
That is the main difference. And then left shift operation you are doing means 1100, there is no problem. So 1 is coming here, 100, same like arithmetic, sorry, a logical left shift operation. Same value we are getting. Okay, so this is 12, right? So 12 is multiplied by 2, that is 24. Then here 16, and then this is 8. So 16 plus 8 is 24.
Yes, sir.
Okay, so that is the multiplication of value we are getting. Okay, so here I am considering that a number 1101. Okay, you are doing the one right shift operation or two right, one left shift operation, two left shift operation, three left shift operation, four left shift operations. So then based on that, see 1101 you are doing that. Okay, 1101 and then 0110. One right shift left shift operation means this one will be vanished and then 10. Okay, this 0 1 0. Okay, so this one is moving this side, one is moving this side, 0. This vacant position 0 is replaced. So this is the output you are getting. Some two zeros, three zeros, four zeros. That's it. Okay, that means all these four values will be going out and this value will be placed at the which position. So 110 is placed at that MSB of 4 bits. See, MSB of 4 bits will be 1100,
Yes, sir.
and then the previous MSB all bits will be shifting outside. Similarly, here A is right shifted by n times, one time, two time, three time, four times. So four times means, so this is normal right shift operation. Then all zeros will be placed at the MSB positions, and then all the MSB positions will be moving to the LSB position. That means 0 here. What are the MSB position? 1101. Okay, that is the MSB positions you are getting at the LSB side, LSB 4 bit side. Okay, so these are the bus width rules. So 4 bit you can consider, and then A is less than 4, and A is right shifted by 4 times, and A is left shifted by 4 times. You can do that. All values should be 0. Okay, so that is the bit rule, bus width rule. And then barrel shifter, like it is shifting the values. See how it is shifting. So this value will be shifting like this. I3 value is shifting toward this, and I1 value is zigzag way it is shifting that. Okay, so that is the barrel shifter. So hardware multiplexer, sometimes we can use some one clock cycle. This is hardware implementation of the barrel shifter. Okay, so that means logical right shift by 2 means it is shifting by just alternatively it is shifting means it is getting that values multiples of 2 only. Okay, right shift you are doing means division by 2. Okay. So then what else here we need to discuss? These are the common mistakes like instead of logical right shift, you are doing that arithmetic right shift. And then shifting out which should be preserved and then so that is not preserved here. And here because it is divisible by 2, so the shifting operator is not preserved. If you are doing the left shift operation only, that bit only it is preserved because it is multiplication by 2 we are considering, then that bit will be considered. Okay, so these are the operators, logical left shift, logical right shift, arithmetic right shift, and then arithmetic left shift. Okay, left shift and right shift. Okay,
Yes, sir.
signed operations are not supported by the logical operators. Okay, here signed operators are supported by the arithmetic operators. Okay, that you can remember. So signed operations when you are doing means that is related to arithmetic shift operators only supported. Okay, see I told you left shift operation is doing means it is multiplication by 2, and then right shift operation is doing means divided by 2. Okay, suppose you are doing two right shift operations, then what is the value you need to divide? 2 power 2. That means 4 value you need to divide. And then suppose you are doing 3 right shift operators, A is shifted by 3 times, then 2 power 3. So it is divided by 8. Okay, similarly, A is right shifted by 4 times. That should be multiplied with 2 power 4. Okay, 2 power 4 means 16. So multiplied by 16. Okay, one time is 2, other time the previous value is considering, right? So then that is also shifted by 2, then total value shifted by 4, and then third time you are doing means shifted by another 2, so 4 into 2 8. In that way it is shifting. Okay, so these are the reduction operators. Reduction operators in between the values we are considering. So what are the reduction operators means? See, and reduction and or not XOR, and then see previously bitwise operations how we are doing 1 0 1 0 are considering, and 0 1 0 1 we are considering means, so in between the bits we are doing that. Okay, bit by bit we are doing that. Okay, bit by bit we are doing that. But reduction operator is not like that. You are doing in between the bits. Okay, so 0 and 1, you are doing the operation like 0. And after that, 1 and 0. So you are doing the AND operation like 0. After that, you are doing the AND operation, you will get single bit operation. Okay, so bitwise operation not like that. So how much bit you are considering, that much bit only you are getting at the output side. But reduction operator is not like that. So in between the operators, in between the bits, we are doing that. See, 1 and 1 you are getting 1, and 0 and 1 you are getting 0. Then you are doing 0 and 1, you are getting the output is 0. Okay, any one of the input is 0, you are getting output is 0. That is the AND operation, bitwise AND operation. So reduction AND operation. Reduction means single value you are getting. See how we are doing that. These two are doing the AND operation. These two are doing the AND operation and getting the single bit operation here. So final answer is 0. And here also OR operation you are doing 1, and OR operation you are doing 1, and OR operation you are doing that 1. Okay, exclusive OR operation you are getting 0, exclusive OR operation you are getting 1. See, exclusive OR here 0 only we are getting. Okay, so he is printing wrong. Okay, 0 and 1 XOR with you are getting the output is 1. And then exclusive OR operation 1 and 1 1. 0 and 1 is 0 here, not 1. Okay,
Yes, sir.
so 0 1 XOR with 1 XOR with 0 means you are getting that 0 value. Okay, so that is the operations. This is the truth tables. So 0 0 means you are getting the AND operation 0, OR operation also 0, exclusive operation is 0, and then NAND operation this is 1. NOR operation you are also getting 1 because complementing of this one, and then exclusive or NOR operation also 1. Okay. So here 0 0 1 means AND operation is 0, OR operation is 1 because 0 OR operation is 0 and 0 OR operation with 1 is 1 and 1 OR operation with 1 we are getting. In that way we are getting the output value. Okay, so see bit reduction and bitwise operators. See how the reduction it is one bit operation, but here it depends upon the width of the your operand. Okay, whatever the operand you are using, that operand width depends upon the value you are getting the width of the bit value.
Yes.
But here only single bit we are getting. See here between the two operations and operation we are doing, so single bit operation we are getting, and then bitwise AND operation you are doing, so 4 bits you are getting. OR operation you are doing, bitwise reduction OR operation you are getting only one operation, and then A or B 4 bits we are getting. Okay, so that is the basic difference between the reduction operator and bitwise operator, because bitwise operation, so here what is the value 0 1 0 0 you are considering, and then what is the another value 0 0 1 1, so 0 0 1 1 you are considering. Suppose XOR operation I am doing here, so bitwise operation 0 0 1 1 0, so 0 double 1 0 you are getting the output side. Okay, so that way we are getting the output. Okay, so here 0 1 0 0 that is considering, and 0 0 double 1 that means 0 triple 1 we are getting the output equation. Okay, so that is the equation. Or sometimes he is considering 1 triple 0 and then 0 triple 1, then you are getting all ones at the output side.
Yes, sir.
Exclusive OR operation you are doing this. See, this is the reduction operators, 2-bit AND operation, 2-bit AND operation, you are getting single bits, and again doing the AND operation, you are getting single bit, you are doing the AND operation, you are getting single bit, again doing the AND operation, you are getting the single bit. Okay, so that is the hardware implementation of the reduction operators. So it confusing the reduction operators and bitwise operators. Reduction operators, so that is also same, but A and you are taking means A is 1 0 1 1. So in between the 1 and 0 and 1 and 1 you are considering. That is the reduction operator. And bitwise operator, so A and B means you are considering means 1 0 1 1, doing the AND operation between the bit by bit. Okay, here in between the bits you are doing, here bit by bit we are doing. That is the basic difference. Clear? So nothing else here. Unknown values here also giving means, so you are getting values like 1 and 1 into 1 unknown value with unknown value means unknown value you are getting. High impedance value you are giving that high impedance value, and then result will be unknown value. So that means, so any unknown value high impedance value you are giving means unknown values we are getting. Okay, so that is not supported by the unknown value and high impedance values in the reduction operator. Okay, so concatenation means combining the two operands. How we are combining the operands? See here, expression 1, expression 2, expression 3, and expression n. All should be combined here. Suppose A equal to 4 tick B 1 0 1 0 you are considering, and B is equals to 8 tick B 0 1 1 0 1 0 1 1 1 you are considering. Then you are doing concatenation operation between the A and B, then you are getting the output like 12 bit 1 0 1 0 1 0 1 0 all ones. In that way we are getting the expression. So that is two operations we are concatenating. See, this is the concatenating operators. And then how many times you are concatenating means it depends upon the bit. See, here also we can use the concatenation operator by using bit scale, bit slicing. Suppose I'm using 8 bits. Suppose 4 bits I'm using 8 tick A equal to 1011 and B equal to 4 tick 1100. Then you are concatenating that. So A of uh, 1 down to 0. That means this is the 1 and this is 0 and this is 2, this is 3. Okay, these two bits only concatenating and then 3 down to 2. Okay, so that means these two bits only we are concatenating. That is the bit slicing concatenation. And then nested concatenating means, see, I told you, A is the value and then B 2 times and then B value should be 1 1. All the values should be combined together. So B is 2 times means 2 times it is repeating. 2B your a repetition operator you are doing. Whatever the B value, 8, 4 tick B, 1 0 1 0 0 0 you are taking. This is 2 times you need to repeat. 2B means 8 tick B, 1 0 0 0 1 0 0 0. In this way, it is considered.
Yes, sir.
Or you need to place the values like 2 times of the B value. See, B value is 0 1 0 you are taking. So I need to consider 2 times 0 1 0. Where is that? 0 1. Okay, 0 1 0 1 2 times I am considering that. So final result is 8 A value is 2 bit, B value is 4 bit, and then C value is 2 bit. So total 8 bits we are getting. Sorry, not 8 bits. Here 2 times, here 2 bit, here 2 bits. So total 8 bits we are getting. Okay. So because B is 2 bits, okay, 4 bits we are getting. And then if you are repeating A also, then 2 bits will be added. Then so we are getting that 10 bit operation.
Yes, sir.
Okay. So here 8 bit only we are getting because 2 A values 2 bit 2 tick B 1 0. Okay, and then A value, that is that B value is also 2 bit, that should be repeated twice. Total 4 bits here, total 2 bits, total 6 bits, and then C value is also 2 bit, total 8 bits value we are getting. See, 2 times of B. Okay, whatever the p value is there, so that is only repeated 2 times. Okay, 0 1 4 bits only, right?
Yes, sir.
And then another operation 2 tick b 1 1 1. So this is the b 1 1 and then 2 bits. So a is, which one is repeating 2 times?
Last one is that it is root it 2 times.
No, if you are repeating 2 times means okay, 2 bit is this, right? So then 2 times it is repeating. Okay, some he is writing that 2D is also repeating 2 times, but he is not representing there. In concatenation operation, not
Root
representing.
it means the 2 times it is.
2 tick means that is the size of your number. That is size of your number. That's it. So not repeating. If you are repeating means, so do the repetition operators like this. So how we are using the repetition operator means, so parenthesis of dot brackets of n comma m. In this way we need to do the operation.
Yes.
So then only it is repeating. Otherwise it is not repeating that many times. Okay.
Then B is
B is repeating 2 times. That's why 4 bit we are getting. Okay, and here 2 bits normally. A is also 2 bits. So then total is 8 bits only. So here it is correct. 8 bits operation we are getting. Okay, so here 10 bits not, 8 bits only we are getting. Okay, 8 bit operation. Similarly, concatenation. See, y equal to 1 and then here 5 bits we are getting. So this is the 5 bit operation we are getting. Okay. So concatenation and replication means this expression, how many times you want to repeat, n number of times I want to repeat it. Okay, so 10 times I want to repeat it, 20 times I want to repeat it. That n outside the bracket is representing how many times you want to repeat your value. That means your b value will be repeating 10 times. So this is expression. Okay, expression means b equal to 2 tick 1 0 you are taking. That means your b value will be 2 into 10, 20 tick you are getting. 20 tick b 1 0 1 0 1 0. In this way, it is repeating 20 times. Okay, sorry, 10 times, and then bits is 20 bits. That is the repetition operator. Okay, how many times you are repeating? See, y equal to 8 times I'm repeating, 8 tick we are getting that, or 8 times I'm repeating 1 tick x. Okay, so that means 8 tick x x x x I'm getting that. Okay, so in that way, repetition operator we are doing that. Okay, concatenation and repetition both are combining sometimes. Okay, so clear.
Yes, sir.
So this is the repetition operator, replication, and then concatenation. Concatenation means combining all the bits, and repetition means so just repeating how many times you want. So that is the repetition operator. Okay, I think replication operator is already completed, right? So these are the operators we are using in what we call Verilog, Verilog operator.